In order to go forward and talk about highest common factor and lowest common multiple and face questions on these concepts in your exam, you need to know the definitions of the words. Let's start with factor. A factor of a number x is a number which divides into x. Therefore, the factors of a number x are less than or equal to that number x. Let's give an example. The factors of 6 are 2 and 3, but they're also 1 and 6 because both of those numbers divide perfectly into 6. We contrast this with multiple. The multiple of a number x is any number which is the result of multiplying x with a third number. Therefore, multiples tend to be greater than or equal to x. For example, the multiples of 6 are 12, 18, 24 and so on, but also 6 itself. A prime number is any number which is only divisible by itself and by 1. 1 itself is not a prime number, it's a unit. Therefore, the first prime numbers are 2, 3, 5 and so on. Many people in the maths world don't consider numbers which aren't prime numbers to be real numbers at all in a sort of funny, jokey sense. When a mathematician sees the number 6, they tend to see it as 2 times 3 because this is its prime factorisation. A number's prime factorisation is a bit like its DNA code. It defines that number and that number alone. 2 times 3 equals 6. It doesn't equal any other number. And 6 can only be broken down into the prime factorisation of 2 times 3. You need to be able to do this skill, to break any number down into its prime factorisation. And we do this using number trees. We start with a number at the top and we break it down through a series of branches until we're left with a bunch of prime numbers which, when we multiply them all together, we get the original number. Let's do this with the example of 24. So we write 24 at the top of the page, we put a circle around it, and we draw 2 lines coming downwards from it. And at the end of these lines, we want to write 2 factors of 24. Let's go for 6 and 4. Because neither 6 nor 4 is a prime number, I'm not going to put any circles around these numbers, I'm just going to leave them as they are. And I'm going to draw 2 lines coming down from both 6 and from 4. 6 breaks up into 3 and 2. 3 times 2 is 6. So I draw 3 and 2 at the end of the branches coming from 6. 3 and 2 are both prime, so I'm going to put circles around these numbers to show that they're prime factors of 24. Going over to the other side, 4 breaks down into 2 and 2. 2 times 2 equals 4. So I write a 2 at the bottom of each of these branches. Because 2 is a prime number, I'm going to circle both of these 2's because they are primes in the prime factorisation of 24. I can now write 24 as 2 times 2 times 2 times 3, or I could also write it as 2 to the power of 3 times 3. The method for calculating the highest common factor and lowest common multiple of 2 or 3 numbers is very similar. At least it starts out exactly the same. If you're given 2 numbers and asked to find the highest common factor of them or the lowest common multiple, you always start by finding out the prime factorisation of each number. We do this using the factor trees I've just discussed. Once that's complete, this is where the 2 methods for HCF and for LCM start to diverge. So I'm going to start off by talking about HCF. I like to think of HCF as the more simple one. We're trying to find smaller numbers. Factors are always smaller than multiples. Because it's the first one and the more simple one, we write out the prime factorisation of our 2 numbers in the simplest way, i.e. just a long string of numbers multiplied together. So if I take this example of 24 and 18, 24 is 2 times 2 times 2 times 3, and 18 is 2 times 3 times 3. You can see by the way that I've written them here is I've written 2's underneath 2's and 3's underneath 3's as much as possible, and now I'll explain why. In order to find the highest common factor of these 2 numbers, we're going to circle common primes. Because both of these have a 2 in their prime factorisation, I put a large circle around the two 2's. And because they both have a 3 in their prime factorisation, I do the same with two 3's. I am now ready to compute the highest common factor of these two numbers. Because I've circled the 2's and the 3's, I take one of each and I multiply them together to get the highest common factor 6. So the highest common factor of 18 and 24 is 2 times 3, 6. This is because these are the two primes which are common in the prime factorisation of the two numbers. Now let's talk about lowest common multiple. As mentioned, to find the lowest common multiple of two numbers, we start out exactly the same way as finding the highest common factor, i.e. we find the prime factorisation of the two numbers. Once we've found it by completing the factor trees, we write it in a slightly different way. Because LCM is the sort of second of the two, it's finding bigger numbers, it's going to be more complex. We write the prime factorizations in a more complex form. We write them in their index form. Therefore, 24 is going to be 2 to the power of 3 times 3, and 18 is going to be 2 times 3 squared. Once we've written out our two numbers in this index form of their prime factorization, we want to circle the highest power of every prime that appears on the page. Let me repeat that. We want to circle the highest power of every prime that appears on the page. You go through the thought process like this. Can I see 2's on the page? In this example, yes I can. There are 2's in both prime factorizations. Which is the highest power of these 2's? Well, 24 has 2 to the power of 3, so we circle 2 to the power of 3. I then ask the same question for 3's. Are there 3's on the page? Yes, there are. Both prime factorizations have 3's. The prime factorization of 18 has 3 to the power of 2, and this is the highest power of 3 we see on the page, so we circle that. I would then ask myself this for every prime until I've run out of primes on the page. At this point, there are no more primes for us to circle. So far we've circled 2 to the power of 3 and 3 to the power of 2. We then multiply these together to get the lowest common multiple of 18 and 24. This is 9 times 8, this is 72. Let me repeat that line one more time. You circle the highest power of every prime that appears on the page. Remember not just to circle the power, also circle the number which the power is applying to. It is also possible to use a Venn diagram for finding the highest common factor and lowest common multiple. When we have two numbers, we draw two circles with an overlap in the middle, and we label one of the circles with one number and one of them with the other. I'm going to continue using the example of 18 and 24. Once I've set up my Venn diagram, I want to write the prime factorizations into the circle for the right number. So for 24, I need to include 3 2's and a 3, as this is the prime factorization of 24. For 18, I need to include 1 2 and 2 3's. Because both numbers have a 2, I'm going to write the 2 in the intersection between the two sets. And I'm going to write a 3 in there as well because both numbers have a 3 in their prime factorization. This leaves an extra 3 in the part of 18, which is not in the intersection of the two sets, and it leaves 2 more 2's in the part of the set that includes the prime factors of 24. Once I've constructed this Venn diagram in this way, it's very easy to work out both the highest common factor and the lowest common multiple. To find the highest common factor, I multiply together all of the primes in the intersection between the two numbers. So here, that is 2 times 3, and the highest common factor is 6. To find the lowest common multiple, I multiply together all of the primes that appear in the Venn diagram full stop, i.e. in the union of the two sets. So here I'm multiplying together 3 2's and 2 3's, giving me again 8 times 9, which is 72. Now let's ask the question of why this process works. In order to demonstrate, I've come to the whiteboard and I've picked two new numbers, 40 and 30. In the box in the middle, I have written out their prime factorizations, And above we've got the highest common factor of these two numbers, 2 times 5 equaling 10. And at the bottom I've got the lowest common multiple of these two numbers, which is 120. A quick reminder, got the highest common factor from multiplying together the 2 and the 5 because they're common primes. And I got the lowest common multiple by picking the highest power of every prime. We've got 2 to the power of 3 here in the prime factorisation of 40, and we've got 3 to the power of 1 in the prime factorisation of 30, and 5 to the power of 1 in both. Okay, so let's look at the highest common factor first. The highest common factor is the highest common factor. It's the factor which is the biggest of both. So let's try and pick one that's bigger and see why that wouldn't be a factor. So the 2 and the 5, let's say they come from here, from the 40. Let's pick an extra 2 and see what happens when we multiply together 2, 2 and 5 to get 20. Well, 20 is a factor of 40. We took it from its prime factorisation. But 20 does not divide into 30 because there aren't enough 2's in 30 for it to divide in evenly. When we divide it by 5, we're left with 2 times 3. And when we divide it by 2, we're left with just 3. This is 30 divided by 10. But then we might try and divide it by the next 2, and we all know that 3 doesn't divide by 2, so we're left with a problem, and 20 is not a factor of 30. This will happen if we add on any more primes to the prime factorisation. Now let's look at lowest common multiple. The lowest common multiple needs to be the smallest number that is a multiple of both of the numbers. So let's try and pick a smaller number and see why that is not a multiple of one of the numbers. If we took one of the 2's out of the prime factorisation of the lowest common multiple, we would be left with 2 to the power of 2 times 3 times 5, which is 60. 60 is still a multiple of 30, but it's not a multiple of 40. This is because there are 3 2's in the prime factorisation of 40, while there are only 2 2's in the prime factorisation of 60. So when we try and divide 40 into 60, there aren't enough 2's for it to go in exactly. Another way to think about this is 8 is a factor of 40, but 8 is not a factor of 60. This will happen if we try and remove any of the prime factors from the prime factorisation of the lowest common multiple, 120. It won't be a multiple of whichever number has more of that prime than the resulting lowest common multiple. Here's a quick example to show how this process still works with 3 numbers. The 3 numbers that I've chosen are 30, 20 and 18. I've written these 3 numbers out with their prime factorizations in this simple method, i.e. they are now ready for me to compute the highest common factor. We can see from this that there's only one prime which is common to all 3 of the numbers, and that is 2. Therefore, we can quickly compute that the highest common factor of these 3 numbers is 2. In order to work out the lowest common multiple, I would need to rewrite this in its index form, and I can do so quite quickly by combining those 2 2's and combining these 2 3's. We're now ready to select the highest power of every prime that appears on the page. There are 2's here, and 2 to the 2 is my highest power of 2. There are 3's here, and 2 to the 3 is my highest power of 3. And there are 5's in both the prime factorisation of 20 and 30. If I take these 3 and I multiply them together, 2 to the power of 2 times 3 to the power of 2 times 5, I should get the lowest common multiple, which is 4 times 5, which is 20, times 9, which is 180. The lowest common multiple of the 3 numbers. And it still works using the Venn diagram method. Here I've got a Venn diagram with 3 circles this time. I've got 30 at the top, 20 at the top right, and 18 at the bottom, each with their prime factorizations written out. Now we need to fill it in. Okay, so every one of the numbers has a 2 in it, so let's stick a 2 in the central region here and stick lines through these. Both 30 and 20 both have 5's in them, so let's write a 5 up here. Both 30 and 18 both have a 3 in each, so we can write a 3 in this intersection. And now we need to simply fill in the rest of the diagram with one extra 2 in the circle for 20 and one more 3 in the circle for 18. Now we can clearly see that the highest common factor of these 3 numbers is 2, the only prime factor which is in the intersection of all three sets. In order to get the lowest common multiple, we simply multiply together all of the primes that we can see in the union, the entirety of the entire Venn diagram. That's 2 times 2 times 3 times 3 times 5, which is 4 times 5 times 9, which is 180.